In the last lesson for Learning Guide 1, we're actually going to be talking about a little bit of graphing again, but more importantly, we're going to get into a formula that's actually going to be used in this learning guide and the next learning guide, and it is the introduction into finding derivatives, which a lot of you probably have heard about because it's a huge, huge part of calculus. And derivative is actually kind of, we're going to talk about how derivative and slope are very similar. And when I'm looking at a slope of a graph, that's something that actually takes you right back to Math 10C. Hopefully when you guys look at this, you're going to see a formula that looks very familiar. So the first thing that we're going to do is look at this curve, and we're going to say, okay, well, how would I find the slope of this curve? Well, because it's a curve, what we would have to do at this stage of the game is find a straight line. And we can do that by looking at a secant line. And a secant line is a line that goes through a graph or through a curve at 2 points. And again, we can draw that nice straight line there and find this slope. So remember this formula y2 minus y1 and so on. So this is going to be x1, y1, x2, y2. So this would become 4 minus 1 over 2 minus 1, which would just become 3 over 1, which is going to be 3. So I know that the slope of this line is definitely going to be 3. Now we can manipulate this a little bit. Instead of finding just kind of like specific points, we can look and see how we can identify a little bit of a formula with just variable points. So here, if I choose any 2 points like a P and a Q, so basically what we're doing is we're making this very general. I know that this first point is going to be X and then f of X. And this next point, so let's say I take this point here, kind of like my x value, and I move it over to here, and I want to relate these. And let's say I want to call this distance between the 2 points h. If that's the case, if this x value is just x, then this x value would have to be x plus h, right? And then here on the next one, I know that instead of f of x, it's going to be f of x plus h. So again, all we're doing is we're making this very, very general so that it works with any 2 given points. And the slope of this is actually, we're going to call that the average rate of change over that function. And again, we're really going to get into this into Learning Guide, or sorry, in Learning Guide 2. So now if I want to find the slope of this, remember it's y2 minus y1 over x2 minus x1. If I want to find the slope using these specific values, imagine this is like my x1, y1, just like what we did before, y2. And so I'm going to have my f of x plus h minus f of x, all divided by x plus h minus x. And now what we can do is simplify, just so you can see in our denominator there. So I've got my slope is equal to x plus h minus f of x, all divided by h. And this, if you guys actually take a quick look at your formula sheet, right in the very top, you're going to see this. And it's called first principles. And this is actually a really, really handy way, long way, but a handy way in finding derivatives. And again, like I said, that's getting us into an intro into Learning Guide 2. Now, what we want to do eventually in calculus is be able to, look at a particle or look at a type of movement. And at any given stage on the graph of that movement, we would be able to choose at any point that we decide, figure out what is the speed or what is the slope at that specific point. And this formula is kind of getting us into that a little bit. So if we read through it, saying tangent lines, as Q approaches P, the secant line becomes a tangent line. So remember, guys, what a tangent line is? It basically touches a curve at 1 point. Okay, so at 1 point there. And eventually, like I was just saying, that's what we're going to get into in calculus, where I want to choose, or I want to find the slope at one specific point on my graph. And what we're doing right now is just kind of laying the groundwork for getting into that. So again, tangent line touches the graph at only 1 point. Okay? And we can use that formula that we just talked about to help us a little bit as well. So it's saying it is important to know that the slope of the tangent at P represents instantaneous rate of change of the function. So at that 1 point P, that's our instantaneous rate of change. So you can see I've kind of drawn these secant lines. And as Q is moving, it's becoming closer to that that P, and we're going to get a line that only touches our curve at 1 point. So this here, just write this formula, this is equal to the slope of our tangent when x equals P, just according to this diagram. Okay. And this, so the limit as h is approaching 0, so this is actually when Q is approaching P. So remember in our last example where we kind of brought in that h value, that was that difference between the 2 points. So what this is saying is that if we limit h, if we minimize it, then obviously Q is getting closer and closer and closer to P. Pretty soon they're going to be the exact same point. So we're looking to see, which is why we have the limit as h is approaching 0. What we're doing is we're saying, okay, well, what's happening to our slope as we're bringing that point right onto P, when Q is approaching P. So when Q is approaching P, h is approaching 0. Okay, so don't worry if this is a little bit confusing, because this is obviously really, brand new. But again, this is kind of doing an application to limits and just seeing, okay, well, why are we doing limits? What's the point? I was saying that we're going to be looking at a graph and figuring out what's happening in that graph, and this is a huge part of it for sure. So if we flip over again, we've got that slope formula. And remember that this, because the limit is h is approaching 0, that means that we are trying to look for the slope at one given point. So take a look at number 15. Find the slope of the tangent to the function f of x equals x squared plus 4 at each of the following points. So in this case, we know x is equal to 5. So according to our formula, we've got basically f of x in there, and we've got f of x plus h. So the first thing probably that we want to do is find f of x when x is equal to 5. So actually plug that in and then evaluate. So f of 5 is going to be equal to 5 squared plus 4. So 25 plus 4, and that's going to be equal to 29. So we now know that that function is equal to 29. And we also, in fact, know that our point is 5, 29. Okay, so we know our x and we know our f of x. Now, if I want to plug this into my equation here, or I'm sorry, my formula, let's do this in a different color. I know that my slope, again, is going to be equal to my limit as h is approaching 0, because remember, we don't want h to be equal to anything because we want to look for one specific point. And now I'm going to plug everything into this guy here. So this is going to be f of, and we already know x is 5, h we don't know, minus f of x, which we just solved to be 29, all divided by h. So again, all I've done is I've substituted in all of our information into that formula. Now we keep going. So the limit as h approaches 0. Now f of 5 plus h, we're going to actually need to evaluate this. This literally means 5 plus h. That means x is equal to 5 plus h, right? So what we need to do is look at this specific equation that we're given and substitute 5 plus h in for that x. So again, we're actually evaluating this for x is equal to 5 plus h. So if I do that, so it's x squared plus 4. I'll just write that out here. X squared plus 4, that's our f of x. So we know that f of x plus h has to be x plus h squared plus 4. Now remember as well, we know that x is equal to 5. So that's going to be 5 plus h squared plus 4. Now we are going to have to, because this is a binomial and I'm squaring it, we're going to actually have to either FOIL it out or you guys can just think about doing it in your head. So that's going to be, I'll just do it the long way first of all, like this. So foiling it out, we're going to have 25 plus 5h plus 5h plus h squared plus 4. Again, let's simplify that. So I've got h squared plus 10h, and then we've got plus 29. So that's going to be our x plus h squared plus 24. I'm sorry, plus 4. Now what we can do is write everything back into our equation. So I've got my f of 5 plus h, which is basically this guy right here. So I've got h squared plus 10h plus 29 minus 29 over h. Just trying to go slow because I know that this is a lot. I shouldn't say a little bit. This is a lot of math right now. And now what we want to do is simplify. So obviously you can see that we've got a 29 and a minus 29. So the limit, as h is approaching 0, I've got h squared plus 10h divided by h. Now, don't forget about all the stuff that we've already learned about limits. And don't lose sight of actually what we're trying to find. We're trying to find slope when the limit is h approaching 0. So remember how we've done, like in the last couple of lessons, we said, okay, the minute that you can substitute in your value, then you do that. Well, right now, we're not able to do that, right? Because we're going to have 0 over 0. That's indeterminate, which we've done a million times. So what we now need to do is figure out how to simplify this. Hopefully, as I'm talking, you guys are looking at your numerator and thinking, yeah, why doesn't she just factor out an h? And you would be absolutely right. So the limit as h is approaching 0. Let's factor out an h. So I'm left with h plus 10 divided by h. Now this is nice because this is obviously going to get rid of our h's. And that's going to give me the limit as h approaches 0 of h plus 10. Now remember, the minute you can plug it in, you do that. So I've got a 0 plus 10, and 10 is going to be my answer. Now again, you might be like, what the heck is 10? What does that even mean? Well, that is my slope at the point x is equal to 5. So I want you guys to imagine this little parabola here, this little happy face, x squared plus 4 is going to look something like this. So when x is equal to 5, okay, so when x is equal to 5, let's say that that's that point right there. What we've just found is the tangent line from that point, the slope of that tangent line is 10. And again, you might be thinking, well, what's the point? Like, why are we, who cares that the slope is 10? Remember that this is going to get us into derivatives, and this is also going to get us into real life situation where if this is a particle moving at that stage, we can find this, let's say, the speed of that particle. And that's what we're going to get into in a few further learning guides. Let's take a look at B, because again, I know that this formula is a little bit tricky, and again, I'll try and go nice and slow. If you can, I would probably pause now and just try number 2, B yourselves, and then just check and see if you got the same answer. Or if you're really lost, just do be with me and then go back, cover it up, try it again, and make sure that you understand. So first we know that x is equal to -3. So if x is equal to -3, we can also find f of x. So f of -3, again, this is our equation right here. So that's going to be -3 squared plus 4. 9 plus 4 gives us 13. So automatically we know that the point is -3, 13. So that's the first part that we can kind of simplify things for ourselves. And now let's write it out. So we've got our slope is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So let's fill in our formula nice and slow. Okay, f of x plus h, well obviously we know that x is equal to -3. We don't know what h is. Minus f of x, which we've just found to be 13, all divided by h. Now what we want to do is substitute, okay, so we need to figure this guy out right now. And if I know that f of x is equal to x squared plus 4, we want to find f of -3 plus h. So that would be -3 plus h squared plus 4. So all we're doing is we're plugging in our x value into that function. Now we can do this again the long way if you want. -3 plus h, -3 plus h, multiply through. So this guy times this guy would be 9. Then I have -3h. I'm just going to kind of pick up the pace a little bit. -3h plus h squared. And then obviously we still have that plus 4 that we need to include. If I simplify this, I've got h squared minus 6h, and 9 plus 4 is going to give us 13. So now what we can do is go back over to our formula. I've got my limit as h approaches 0. That, what I've circled in the green, has simplified to this. So I'm going to plug in h squared minus 6h plus 13 minus 13, all divided by h. And now we can simplify, and you'll see this looks very similar to the other one that we did. 13 minus 13 is gone. Limit as h approaches 0. You can see in the top here that obviously we can factor out an h. So I've got h minus 6 over h. Again, just like before, those guys are going to cancel. And I'm saying just like before because you're going to notice this quite a bit. Your numbers are going to cancel, and your h on the bottom is always going to cancel. And now we've got the limit as h approaches 0 of h minus 6. Now we're at the stage where we can absolutely substitute it in. So I've got 0 minus 6. So we know that our slope at this stage is going to be -6. Again, what is -6? It's the slope at the point on my curve of -3, 13. Okay, so double check that, make sure you're good. We're going to do one last example, which is this one, and then I really encourage you, this is important. And you're going to see the first principles, like I said, not only in this learning guide, but also the next one. So number 16 is saying, again, find the slope of the tangent to this function. So you can see that we've got a little bit of a trickier function this time at x is equal to 5. And we're using this formula right here. So first thing that we probably want to do is find what is f of x when x is equal to 5. And I'll actually just even write my 5 in there. So that's 5 plus 1 over 5 minus 2. 6 over 3, which is going to leave us with 2. So we know the point that we're looking at is 5, 2. Now let's bring it over to our formula. Substitute in everything that we possibly can. So I've got f of x, which we know is 5 plus h, minus f of x, which is going to be our 2, which we solved for already, over h. Okay, just make sure that all makes sense. And then next, obviously, this guy is still the kicker. We still need to evaluate this, f of 5 plus h. So I'm just going to bring that over here, equals, and remember that means I'm substituting every x with 5 plus h. So I've got my 5 plus h plus 1 over 5 plus h minus 2. This would simplify to 6 plus h over 3 plus h. Okay. Now I can bring that back into my formula. So I've got the limit as h is approaching 0. I've got 6 plus h over 3 plus h minus 2 all divided by h. Now at this stage, I mentioned before about having fractions in your fractions, and that's always something that's not ideal. We always want to try and get rid of that. So the first thing that we're going to do is we're going to simplify our numerator, and then we're going to make this a little bit more lateral. So we're going to actually subtract these two guys right here, because this is the same as negative 2 over 1, right? So our common denominator is obviously going to be 3 plus h. The 6 plus h, we didn't have to do anything to, but my 2, I'm definitely going to need to multiply that by 3 plus h. So if I multiply that, I've got negative 6. So 2 times 3 is 6, minus 2h. All of that being divided by 3 plus h, and all divided by h. All right. So now what we can do is simplify this again just a little bit. So basically I've got my 6 plus h minus 6. So obviously the 6 minus 6 is just going to cancel. I've got h minus 2h. So let's go ahead and move down a little bit to the limit as h is approaching 0. I've got h minus 2h, which is negative h, over 3 plus h. And remember what I was saying, guys? This guy here, we can just move over to the side, and it's just going to be times 1 over h. So for those of you, if you're getting a little bit lost, this became this, and this is now this. Now if we move forward, and again, we're trying to simplify here. Obviously, h and h, that's nice and easy. We're going to cancel those. So we're left with the limit as h is approaching 0 of negative 1 over 3 plus h. And luckily at this stage, we can definitely substitute in h is equal to 0. So this is going to become negative 1 over 3 plus 0, which is just going to be negative 1 over 3. So all of that work, that's what I love about this course. You'll do a whole page of work and you'll get a nice answer like negative 1 over 3. And again, don't forget, what is that? That is the slope at the given point, x is equal to 5. Guys, this stuff is not easy. So what I really encourage you to do, I've mentioned it a million times, do the practice, that page 35, see the help desk, talk to your teacher, and make sure you practice this.